Hi, everyone. Good afternoon, and thank you to be here with us with this amazing panel about art intelligence, a discussion on the limits of artificial intelligence and how they related to art. We have Bruno Caldas Vianna, Sofian Audry, Ramon Lopez de Mantaras, and remote, Rosemary Lee. Thank you very much.
Thank you, everybody, for coming here after lunch. I hope you're not too sleepy this time. We're going to just do a round of presentations and provocations from us, and then we're going to immediately open for questions. We're not going to have like a close discussion, so just keep your questions so we can start talking between all of us immediately. So I'm just going to introduce quickly what was my intention on proposing this. I'm a PhD candidate exactly on visual arts and AI. And as I review the literature, there's a lot of, it's been like through the ages, like this comment that what's missing for AI is creativity. It's like not, it's the one missing ingredient that we cannot achieve. So these are quotes like from, of course, Umberto Eco and Douglas Hofstadter, which is mentioned in my paper earlier. And he's also very passionate about music, and he wrote this in this seminal book called Goethe, Escher, Bach. And this is a more recent quote from Margaret Boden. But then there's another quote from the same guy, Hofstadter, when he solved the first music-generated algorithms. And this was like, EMI is like a very like symbolic logic, not neural networks, very old. And he was already terrified by the fact that, yes, computers could simulate the kind of a human composition. And he was said this means something for mankind. And of course, the methods for creating artificially generated music and images and texts became much more powerful in the last decade. So it will be, I don't know how he feels these days about that. But curiously, there's still some, not curiously, but I think it's very clear that the idea of that Umberto Eco mentioned about the difficulty of creating metaphors is still present, and I like to use this example from OpenAI Playground, because they do have an analogy maker. You can just type two things, and he asks the GPT-3 model to create an analogy between the two. So if I just put some really random concepts like keyboards and stars, and he would write an analogy between keyboards and stars. But of course, that's only, it's already like giving up the result of the analogy. I mean, when I say your eyes are like stars, we have the context shared that we know that you're talking about how stars are bright, and then when I give the two elements of the metaphor to the computer to relate them to, and he's not creating a new metaphor. He's just like blending two concepts and what they have in common. In any case, it's very impressive that this can be generated by a model these days. Like stars are, just as stars are the keys to unlock the mysteries of the universe, keyboards are the keys to unlock the mysteries of the internet. So it's, and that's all this, what's interesting is that, okay, we always say that, yes, AI is very advanced, it can beat humans in chess, can beat humans in chess, but there's something, it cannot make Van Gogh paintings, and then there comes a model that makes Van Gogh paintings or Rembrandt paintings. So the goalposts is always moving. Like there's something that we cannot do, and then suddenly it can do. But it's like going in infinitesimals. Like you can never reach this point where we can recognize this as a really like original and creative thinking, because of course all the models we have now are trained on existing music or text and images, so it's not really able to create a new concepts. So the way I started to think, and I needed help from a panel like this to help me understand and maybe advance the discussion a little bit, and especially with the audience, is like this idea that we have our biological intelligence. There's stuff that our AI does much better than us, especially like big calculations, and there's endless examples where a machine would do better than us. But there's one part of our intelligence that the machine cannot reach, and this is very similar to art. So that's the idea of proposing this idea of some kind of art intelligence that cannot be reached by machines. So this is what I wanted to propose as a provocation. Now I'm going to present a video from Rosemary Lee, who could not be present, but sent a 6-minute video with her proposals. And if everything works now, let's see. One more. Okay. Okay.
Hi, I'm Rosemary Lee, and I'm an artist and researcher with a background in media studies. The past few years, my work has centered on the influence of algorithmic processes in image production and how this connects to the history of visual technologies. I've been specifically looking at how the incorporation of machine learning into artistic practice shapes the way we think about images. And I've recently released a video entitled Myth, Magic, Machines, reflecting on the mythology surrounding artificial intelligence. This extends from my PhD research, in which I looked at how discourse on machine learning in contemporary art is informed by longer historical narratives surrounding technological forms of image production. I've subsequently been writing a book adapting that work into a more accessible form with the working title Algorithm Image Art. And one of the core arguments of this recent research is that while machine learning is a relatively new paradigm of image making, it touches on a number of issues which have been explored at length in the history of art and in theories of the image. For example, questions concerning the value, authorship, meaning, and truthfulness of images have become intimately connected with technological processes, especially since the widespread use of photographic and later digital media. I've been looking at parallels between aspects of machine learning and older forms of image making, such as analog approaches, where images are formulated in terms of highly structured procedures and proportional relationships within visual compositions. I'm also interested in cases where unified images are produced by combining or analyzing aspects of multiple images or visual data. This connects to longer threads in my work, which is deeply informed by the approach of media archaeology. Media archaeology seeks to better understand contemporary media artifacts and contexts in relation to the longer historical tendencies that shape them. It often looks at early precursor technologies to those of today in order to gain a better understanding of how current methods devices, or perspectives are related to those of the past. So, for example, we may look at pre-cinematic devices in order to better understand film or digital media. Adopting what Siegfried Zielinski calls a deep time perspective of media allows us to draw insights from artifacts from the distant past, in contrast with the common tendency to exclusively consider technology in terms of the new. I've also been quite influenced by post-phenomenology's understanding of the feedback loop between how we see and the design of technologies that in turn augment visual perception. For example, photographic and painterly aesthetics remain influential in art working with machine learning, in spite of the fact that very different processes go on behind the visual surface of the image. One of the points I'd like to problematize in this discussion is how the structuring effect of algorithms also affects the way we view relationships with visual media. For example, the myth of the machine as artist, as Andreas Brockman calls it, has been a common trope in art working with AI, typically emphasizing the idea of an autonomous artificial agent that assumes authorship over the creation of art. This draws on ideas that have been present in discourse on art for quite some time, such as the idea that in photography it may be the camera and not the human wielding it that is primarily responsible for the image produced. Similar ideas come up in Joanna Zielinska's conception of non-human photography, which she describes as not being principally of the human, by the human, nor for the human. But while I appreciate the idea of non-human photography, it appears to undermine its own aims by forgetting the role of humans in conceptualizing, designing, building, and maintaining even highly autonomous visual systems that are also highly attuned to the parameters of human vision. I believe Sofian Audry's proposal of art without artists is an interesting turn on the concept of the machine as artist. It diverges from other perspectives that typically mystify artistic authorship at the expense of the actual work that is produced, and the idea that technically engaged artifacts are imbued with the aura of their medium. This is something that may become even more relevant to think about as tools involving AI or machine learning become more accessible, and artificial intelligence may lose the air of magic that it currently has. So to close, I'll end with an open question that I think we can come back to in the discussion, which is, how does it influence our view of art if we rethink the role of the artist as enriched by, rather than competing with, technology? Thank you so much for your attention. I look forward to the discussion.
We're going to try to get Rosemary's to hear the panel and bring questions if she has. So I'm going to pass. You can operate this. I'm just going to switch the file. Okay.
We have to get back to the first slide.
Oh, sorry.
Hi everyone, so I'm Sofian Audry. I'm a professor at the School of Media at Université du Québec à Montréal, and I'm also the co-director of the Hexagram Network for Research Creation, Art, Technology and Culture in Montreal. And I also have released a book last year, which some of you might be interested in, called Art in the Age of Machine Learning, where I have been looking at the history and both in terms of the history of science and history of art, trying to disentangle the myths surrounding art making with AI and machine learning especially, and looking deeply into practice across visual arts, digital arts, music, and literature. And I want to use my time today to maybe talk a little bit about some of the most provocative questions that were brought forward by this book, and also since the publication that I'm also working on some of my own creation projects, which I think could also bring up some interesting questions. So the first big thing I think that I want to share today is that there's this there's this big idea that's been portrayed a lot in the media, and Rosemary just talked about that. The idea that, you know, we could make art without artists, and one of the I think one of the contradictions here is that the missing part that we have at this point is that we often the research that is done by engineers who are not really aware of the contextual of the fact that art, at least since the beginning of the 20th century, has become largely contextual and part of the discourse. So we're trying to generate interesting images, but we're actually perhaps missing the point, but perhaps not. So on the left, you see an image from a study that came out in 2017, the Creative Adversarial Network. And the researchers in this did something really interesting. So they trained a certain kind of GAN, of neural network, on images from the taken from all across the board from the art world, and after that they tested. So they tried to pass the Turing test basically with their system. And what's really interesting is that they asked a number of questions to, you know, a sample of people. And so in terms of, for example, so when people were asked, so they were shown an image, they didn't know if it was made by a machine or a human. So when they would show an image of American Expressionism, which is a really well-known art form, people would say, 85% of people would say, this is done by a human, and they were right. And then when they were showing one of their generative images, 53% of people would say, this is done by a human. So, you know, they passed the Turing test. Good job. What's really telling is that when they also showed some pictures from the latest art fair in Basel. And when they would show these pictures, only 41% of people thought that they were made by humans. So basically, people in general think that contemporary art is not human. So it just shows a bit one of the problem with using AI, and particularly machine learning, to try to make art, is that if you're trying to optimize, you have to optimize something when you use machine learning for art. And if you're trying to optimize public, general, you know, taste, it doesn't mean you're generate interesting art. You know, you're generating these images that come out of nowhere. This has a link to, like, in the mid-90s, the painters Kamar and Millen did a series of painting that were kind of playing with that idea. So they had at the time they ran a big survey, and they asked what people liked to see in a painting. And based on that, they generated the picture you see on the right, which is the America's Most Wanted painting, with everything that people like in a painting and not the things people don't like. Another thing I want to add quickly is that I think AGI is kind of contradictory, and this actually comes not from me, but from Yann Lacan, who's the head of chief scientist at Meta, and he said, yeah, and I agree with him. There's no such thing as artificial general intelligence because there's no such thing as general intelligence. Human intelligence is actually very specialized. Intelligence is about adapting to a specific context, once again. And so to think that we might have an intelligence that would be completely general is kind of a contradictory. One thing that's very interesting about machine learning is that in a way, it sort of defies human understanding. When we used to have artificial intelligence that was just based on rules, it was possible to explain them. So back in the days where I was using rules to make behaviors for robots, for example, people would always ask me a very annoying question, which is like, they wanted to know how it worked. And I could explain it because, you know, there were rules in the system. And today I can say, well, I actually don't know how it works, so you're going to have to experience it phenomenologically. This is an example of a piece I did recently with Istvan Kantor, where we created this system that is trained on Neoism text. So Neoism is an avant-garde movement, international movement platform for subvertainment and brainwashing. And it's kind of a mix of pataphysics and punk rock. And so the machine has been trained on Neoist text and can generate ad nauseam new text. What was interesting, well, what I think is interesting about the piece, the idea of the piece is that you see all these cables on the machine, and each of these cables actually corresponds to a number like about 10,000 to 100,000 connections in the neural network. So it kind of materializes the neural network that generates this text, and you can actually unplug things, and then it starts to completely deconstruct itself. And I don't know how this machine works, really. Like, you have to really experience it and play with it. And what's really interesting is that you see this text, and it becomes quite fuzzy at some point, but somehow your brain starts reconstructing new text and new ideas. So even if it's in a very unstable state, it still talks to you and brainwashes you. So another thing I want to say today, and this actually came from some reflections I had recently here at IZEA, is that the idea that we are in this kind of progress towards some kind of general intelligence doesn't make sense, because this is not how evolution works. You know, we're kind of like a species among like millions of species that are just swimming in this soup of DNA that there's not really any objective function to that. So we're not going anywhere yet. I put the not in parentheses because we are going anywhere. So in my own work, I've been exploring this idea of looking at, you know, what are the interesting things we can do with these technologies. And the more I am experiencing with them, the more I believe that what makes them so maybe transformative for the art world is that they allow us to articulate materially different kinds of agencies together. This piece is a work in progress called Xenolalia with artist, co-collaborator artist Tez, in which we're creating this system, bring together a neural network and a colony of microalgae. And they kind of like interact with one another, and slowly there's these kind of images that grow out of, oh, the GIF doesn't work. Oh yeah, it's a PDF, I put it in the PDF. Okay, I'll go back to this image. So what you see on the right is this apparatus that brings creates this kind of dynamic. And it runs over about 15 minutes to generate an image. And there's this kind of exchange where the neural network will propose a first kind of shape, and then the colony sort of stabilizes around that shape because they're kind of seeking light, but they don't work like like, you know, digital machines. Sometimes they actually don't work at all because they're, I don't know, maybe they're asleep. But they will create this kind of imperfect response or their own response to the image that's suggested. And then this is fed back again into the neural network. And our idea was that to generate this kind of strange alphabet that kind of comes out of this relationship between different kinds of hybrid agencies, the human, who are there too as like trying to interpret this. The neural network was also trained on handwritten digits, so there's kind of a bit of human in everything and a bit of non-human in everything. The neural network, which is again this hybrid, you know, approximation of biological systems, and then these algae that have a single photocell, so they're kind of ancestors in a way of the kind of, they have similarities at least with the kind of cells we have on our retina. And so you could see this as both a living photographic film, but I also like to see it as kind of an artificial retina. Another thing, another provocation for today is that creativity, and especially computational creativity, is often seen as a property. So Elizabeth Bowden, for example, has been really famous for coming up with this, these principles for creativity, which I think are really interesting. So basically she says, you know, creativity is both novelty and value. So you have to have something that's novel, but if it's complete chaos, you know, it doesn't really work. And I want to argue something against that, as maybe creativity is not so much a property, this is something creative, but rather an activity that comes through a relationship between matter and between the world and so between different kinds of materials and agencies, basically. So what you see here is one of my favorite pieces by the visionary artist Nicolas Baginski, who in the early 1990s created a robotic band that were completely self-supervised. So you use unsupervised neural networks and using this in a way where as opposed to approaches that were very popular, that started to be popular at the time in computer music, where we were rather trying to, for example, train a neural network on pre-existing scores and then generate more scores. And Baginski said, I was not interested in this because this was just a way to generate more of the expected. And rather, he put these things in the world, and they played their own music. And for years, he actually had them rehearse. He had them listen to. So instead of like training them directly on scores, he had them listen to music of artists that he liked. And maybe I can stop here with that last piece of mine that is also related to what I just said. This idea that the creativity comes through the relationship that we develop between one another and between the systems and our environment. So I don't know if you can play the video. So this is a work in progress with artist Rosalie Dumont-Gagné, and we've been working on that for a few years already. And what we're trying to do is to, so we have these robots that have different kinds of shapes, and but they have kind of the same mechanism. And what you see here is one example of a behavior which we generated, which we were really proud of, because it's absolutely impossible to work with these systems. And what you see here is that these systems are trained in real time using reinforcement learning. And we are trying to create behaviors using theological, like objective functions, because that's the way we have to train them. So in this case, we actually tried to train the robots to try to move their motors, but without moving, so without any displacement. And the result of this is this kind of dancing behavior that happens, where they found a solution to that objective, but you wouldn't necessarily know what is the objective here. It's really their own kind of expression that happens through their own experience of the world. And so if they have different shape, they will not behave exactly the same. And also depending on what the events that happen, if somebody touches them or if they bump into another, they will also not learn exactly the same thing. So I will end here, and thank you for listening.
Good afternoon. Thanks for inviting me. I'm going to be a bit controversial about everything, not only about AI, obviously about AI, and in particular about AI and art and creativity and all this, which is the subject, the theme that we are dealing with today. I actually agree with Maggie Bowden's opinion about the main difficulties, problems that AI has not solved. That has to do with language, creativity, scene understanding, and things like this. When you look at these difficulties, one can see that what they have in common is that these are this kind of tasks or problems that to deal with them and to properly deal with them and to really understand when you see something or to understand a text, what you need is something that is lacking in machines, and we don't even know in artificial intelligence how to progress towards this problem. The problem I'm referring to is common sense knowledge. So the knowledge that explains simple things about the world, that let humans, as humans, to know how the world around us behaves. That to move an object which is attached to a string, I need to pull the string, not to push the string. So there is millions of very little units of knowledge that are completely obvious for all of us, because why we are obvious? We didn't learn this in books, not in school, not in university at all. We have learned that because we are living and sentient beings, because we have experienced that since we are born, no? And this is the main difficulty. We have been struggling and hitting our heads against this wall since the very early years of artificial intelligence. John McCarthy, one of the fathers of artificial intelligence, and the one who, by the way, proposed to call this field artificial intelligence, already in the late 50s wrote a paper called Programs with Common Sense, and addressing this issue and pointing out that this is one of the crucial aspects of artificial intelligence, right? In Melanie Mitchell's book that you have referred to, he quotes Douglas Hofstadter, which I had the chance to meet several times, because I've been working a lot on analogical reasoning, and Douglas Hofstadter, one of his main activities was also analogical reasoning. And what he says, he was obviously wrong in his sentence, and then when in one of the sentences you showed before in the night of 1986, already very early, quite long ago, and then he was astonished, and this is the quote in Melanie Mitchell's book about the developments of AI. No, but it is not surprising actually that it looks like a contradiction. On the one hand, he's a very good expert in analogical reasoning, and metaphor has a lot of obviously metaphors are analogies actually. And so he says how a person that had this very strong knowledge about how hard it is to achieve that a machine is capable of doing analogical reasoning and analyzing, understanding metaphors, and that all of a sudden he seems to concede or to accept that the AI has this ability of understanding metaphor. In the OpenAI example that you gave out about stars and keyboards, this is a good metaphor. Actually, the metaphor is nice. I will not deny that. But we have to be very clear. We should not be fooled. This OpenAI has not idea at all of what a star is and what a keyboard is. Let's be clear about that. So, because I'm worried about the situation of nowadays of artificial intelligence in general, and then in artistic and art and computational creativity, computational art, there is this over-expectation and an excessive anthropomorphization of AI. And we believe that AI is capable of, has been solved, has been even people who have said, oh, AI is solved. General AI has been already solved. Somebody said that by the way, who works for OpenAI. And this is actually not true at all. We have not solved the problem of AI. The intelligence in artificial intelligence, we should be written always in between quotes, because artificial intelligence are not intelligent at all. Are not intelligent in the sense that we normally understand what intelligence is. And what we understand about intelligence, well, we don't know very much what intelligence is, let me say that. I agree with, I concede that. But when we see one, we recognize one. And we know what is, we know how to identify an intelligent behavior. We can query another person, and we can ask a sequence of why questions. And by asking why questions, we go much farther deep. We don't stay at the superficial level of understanding. And if the person we are asking why question is capable of giving us answers, good answer about the whys, then we are more and more convinced that this person actually understands and is actually intelligent. Of course, in the case of AI, that never happens. You cannot ask even the first why question to any AI system. This is very well known, this problem of the lack of explainability of deep learning, for instance, right? And that is one of the big hot topics in artificial intelligence research, how to make these systems capable of doing some sort of logical reasoning, that this logical reasoning will be able to provide an explanation. Since these neural networks do not do any reasoning, there is no logic behind it. I think you showed, right, at some point that Yann LeCun sentence about there is no general intelligence, and that human intelligence is a specific intelligence. That the human intelligence is a specific intelligence. Well, again, that may be controversial. I don't agree at all with Yann LeCun's sentence. I mean, he's completely wrong, unless he has a very weird definition of what general intelligence means. But to me, general intelligence is something is being multitasking, being an agent is capable of doing multitasking. Any one of us, even if we are specialized, even if I am a computer scientist, you're a mathematician, you're an artist, whatever, we don't only know about our speciality. We have all this knowledge that we have been acquired along our lives, which is the common sense knowledge on the one hand, and this is general knowledge. Common sense knowledge is general knowledge and is a characteristic of general intelligence. So unless Yann LeCun considers that common sense knowledge is not part of human beings, is not part of general intelligence, then maybe he's right. But that would be very weird to rule out common sense knowledge and all general knowledge and put it outside, and not including this as part of the characteristic of the general intelligence of human beings. When we read the newspaper, we go through the sports section, to the economy section, to the international section, to the politics section, to I don't know, maybe we will even solve the crosswords at the end of the newspaper, or and newspapers have even comics, and we read the comic, look at the comic, and we laugh. Come on, this is general intelligence. We are doing a lot of diverse things. A lot of diversity. We are not specific. Sorry, Jan LeCun, but you are completely wrong. Completely wrong, okay? And it's disturbing to me. I've been in the AI since, my first paper in AI was in 1976, come on. I mean, I've been in the kitchen of AI for more than 40 years. And now comes someone and tells me that, you know, that general intelligence, you don't need artificial general intelligence because general intelligence doesn't exist. Come on, he's throwing through the trash all the work of Jean Piaget on developmental cognition, and he's throwing in the trash lots, millions of things that have been done in the world in science. This is not fair. I'm sorry, this is not fair. Sometimes I get a bit angry about these statements. Okay, scene understanding, language understanding. Deep language understanding, nothing to do with deep neural networks. That is, they have the deep in them, but they don't understand, right? If you tell an AI system that John was, for example, a Friday night, and he had late dinner, and he had no cash, and he went to the only cashier in his village, and the cashier swallowed his credit card. And then coming back home, he met a friend, and they went for a beer. And they had more than one. And he got home quite happy. We all understand things, and we can answer lots of questions about this paragraph. We know that he lives in a small village, because there's only one cashier. I forgot to say that they got the beer, they drank the beer in the only bar of the village. So we know that it's a very small village. We know that he had no cash, that he could not pay the beers. Maybe his friend paid the beers. Or maybe, because it's a small village, they know him and they say, okay, you will pay tomorrow. But he could not pay tomorrow neither, because that's Friday night, very late in the evening when this happened. And banks do not open until Monday. So he could not recover his credit card, and he could not go into the office and get money. How do we know all that? All that was not in this paragraph. How do you understand all that? Because we have general intelligence, because we have common sense knowledge, because we know a lot about the world that surrounds, that we are living in. Okay? Machines have nothing of that. Have nothing of that. Machines, by the way, they are not creative, neither. There is no art without artists. There is no art without artists. In any AI system, there is always, not one, a lot of people involved behind, designing the system, designing the algorithm, programming it, everything. And they take lots of decisions. The intelligent decisions are taken by the people. And then the machine does very interesting things. I agree. Take DALL-E, for example. No, DALL-E, yes, produces nice things, but he doesn't understand a single word of the prompt sentence. And in the version that produces images and with a caption, he doesn't understand anything at all. So be careful. And art will always need humans, always. I mean, you cannot, build a robot and then plug it in and expect that something will happen. We will do nothing. We'll be completely nothing. It will be like electro-appliance. It will do the same thing as an electro-appliance. It has to be programmed, and it has to be lots of lines of code behind, with lots of people that have been developing the software that allow this robot or machine to do something eventually interesting.
Thank you, Ramon. I would continue arguing, and I think it's very, very provocative. But I really want to share the microphone with the audience and see if anyone has questions, want to. I'm just going for the wireless mic.
Thank you. So thinking about artificial intelligence, I've been around at least long enough to remember AI 1.0 and how the roboticist Rodney Brooks wanted to blow up the research in the early AI by considering that intelligence must be embodied. Is this not coming through?
I could not hear very well.
Okay.
I missed many words.
Okay, so I want to think back to AI 1.0, the early AI, early artificial intelligence, that Rodney Brooks, the roboticist, Australian.
Rodney Brooks?
Yeah,
Yes.
so Rodney Brooks discussing artificial intelligence.
Yeah, intelligence without representation.
Exactly,
Yes.
intelligence must be
Behavior-based.
should be embodied. So, and then later on we approached the question of human intelligence, and this has been said earlier in the conference, of course, that intelligence is not the attribute of a system, it's an activity. So similarly, human intelligence is not the attribute of a particular brain, it is socially constructed.
I agree with that.
Which is to say it's distributed, it is certainly embodied, and this I connect back to Rodney Brooks. And finally, it is embedded. It exists because it is pieces of the environment. I will not be nearly as intelligent here in the middle of the desert as I am here right now with this microphone. So I guess my question is, okay, can we have an AI that is embedded, distributed, and physically available, embodied, in short? Or is it simply that if there is an intelligence, we're not going to recognize it because it's going to be so bizarrely different from us that it will fulfill none of these standard expectations for the kinds of activity of intelligence? I put forth the extreme possibility that we already have some sort of artificial intelligence operating in the world within our distributed networks, but we have no idea what the nature of it is, because it has its own particular kind of distribution.
I know, you want to say something? Well, this is quite a hard question, actually. I'm not 100% sure I followed everything to the very end, but if there is an artificial intelligence, even if there is one, or in the future there will be one, whatever it is, whatever it will be completely alien to human intelligence, something completely different. Of course, there is all this trend in artificial intelligence called biomimetic, right? Trying to copy at the lowest possible level even how the brain works and everything. Actually, these convolutional networks that are behind deep learning and other type of networks, and the transformers and all that, they are based on loosely inspired in some ways that our brain may work, specifically dealing with vision, when there is hierarchy of stages where you first identify little features in the image, like dots or straight lines, and then at the second level they form circles and squares, and then at the next level and so on, the representation is getting more and more complex, and at the latest level you may recognize a face or a cat or whatever, yeah, as an object, right? This is loosely inspired by the way our brain works, the visual cortex and all that. But this is one of the exceptions, in my opinion. For most of the AI that we are doing is not biomimetic. It's not biomimetic. It's done. You achieve some behavior that looks intelligent by other means, not necessarily mine. After all, planes don't fly doing like this. Okay? The propulsion of a plane has completely different from the propulsion of a bird. So this is a very good example of how you can achieve some similar behavior in ways different from what nature achieved, ways that the nature were achieved. So if there is an intelligence that we don't know now or will be in the future, I'm completely sure that will be completely different and alien to ours. And that's a good point to make us think about ethical aspects of AI. If it's alien to human aspects, and in particular human desires, human intentions, human whatever, human values, we should be careful. And we are already witnessing some problems with some artificial intelligence that they are you know, ethically very controversial, to say the least. And but again, they are not like this because they have intention of being bad or being racist or being I don't know what. No, they are like this because the human who designed them are the ones that are the ones to blame, okay? Because they didn't train them with the appropriate data. The data sets were biased, discriminatory, racist, and they didn't take care enough, they didn't look enough to minimize this bias, and then what comes out is something completely unacceptable that has to shut down, like happened with this bot in Microsoft long ago, and has happened with some face recognition software by Facebook, I think, or Google, whatever. Any of them could be, so no problem. That took some black people as gorillas, labeled black people as gorillas, right? And we have these kind of things that, because, we are anthropomorphizing AI too much. We shouldn't do that. We shouldn't. That is completely alien to that, to us. But that doesn't mean that we should not try to get the AIs more and more general, because that they would be much more efficient instead of being trained every time for a new task and solve the problem of catastrophic forgetting. That you train an AI system to do something, when you train the system to do something else, forgets completely what he was doing before. This is called catastrophic forgetting, like this in AI, right, in the field. And we have to solve these problems to have more general, more multitasking AIs. But let's forget about super intelligence, about singularities, about these human-like intelligences, because this is not the right way, I think.
To add to this, this comes from Jürgen Schmidhuber, who said once that was really interesting perspective. He said, like, if there are some kind of singularity one day, because I think it was in a panel where he was asked about the singularity and the threat to humanity, and he said, I think that if AI ever, if we ever manage to create these, maybe even like super intelligent, like beyond human intelligent AI, they won't really care about us. Like he said, they probably, and he said it's a bit like, like people who go to IZEA, we have our own world, and we're like, we talk about stuff that a lot of people don't really care about, or like little girls who play in the school backyard. They're in their little girl's world. Like they don't care about, like, about the rest of the world. So it's like we actually live in these little bubbles, and probably that the AI also, but by bubbles I mean maybe back to von Weck's concept of the world. So we live in this very human world, and I think this is, to me, this is how I read Jan LeCun, because I don't think he thinks that we're not. I think by the way I read it is by, he says, human beings are living in this human being, with this human being intelligence in this human being world, which is very much adapted. I mean, our brain has not really evolved since, you know, for thousands of years. So we're adapted to that, and we have capabilities and forms of intelligence that are very general. We're able to learn a lot of things, but there's also, like, I don't know about, like, I don't know about you, but I'm unable to remember a lot of things that I wish I would, like, remember where I left my keys 5 minutes ago or things like that. I don't have this kind of, and I can't perform like as many calculations as a computer. So yeah, so I mean, I think this maybe is if we project ourselves, maybe we could think about if, and I don't think I think we might reach some kind of human level AI, but definitely we're really far from it. We're still in this imitation game, right? We're still in this thing where we have these toasters that instead of pushing out toast, they push out like images of astronauts on the moon, but they have no idea what they're doing. So we're still stuck into this the Searle's Chinese room in a way, and it doesn't mean we won't find, like, we might. I mean, I hope we might find some better principles, but I think we're really far from it. So.
Well, I would like to, well, first of all, I've seen the film Dune lately, and the planes do fly like this, just by the way. Well, I want to relate a story about, with Sofian that I met in the mid-2000. And like, I run an artist center who's interested in digital narrativity, and then this guy, Sofian Audry, proposes a project like of creating some kind of entities that would learn from words to words, and it was a little bit nebulous. And but he said, "Oh, but it's very cool. It's very cool. Let's support this artist." So we started to work together and to create Vivi, and then it was. I remember I don't remember that we talked about intelligence, artificial at the time. Not really. Like, which was just his dropout, you know, like Luby or fantasy to program, something like that. And the thing was, the system at the end, because it worked. It finally worked. Congratulations, Sofian. And then the idea was like the system would you say create a Vivi, and then the system would send you a word like sit. And then, you could type another word like chair. And then the system would send another word like wait. And then wait, doctor. You type doctor. And then the system would send another word like a disease. And then you would type, let's say, cancer. And then the system would send another word like nurse, because the system would have learned that doctor, cancer, and nurse belong to the same not syntactic, but semantical field. Mm. And then when you could play like that, and then words would multiply, and some words would totally wide and will like go totally out of the field, and some would really fit with the world that you were creating. And then you could save your Vivi and start another entity, and that was very fun. And then we went to remember, we went to a literary festival. We brought the computer, the big iMac, and we had the people to play on them. Like, that's in 2007. It was like literature was not yet digital, really, you know. So that was an interesting experience. And then, like, I know, like, there's the kind of the big crunch of the 2010 with the explosion of chips. And then what happened ever since so that, well, like, artificial intelligence has grown so much.
But if I want to say something about that, because that's a really good example, because I mean, that was a really simple system based on kind of word clouds. And there's two things that I think are interesting. First of all, my intention with that work was to create these kinds of little agencies. But I think it turned out that this is not necessarily how people adopted them. They became much more kind of little compositions. But instead of a composition that was like a text, you would save this kind of generative poetry system that sort of belonged to you a little bit because you could put your own words, but it also went to fetch words that were inputted by people. And all the words were, there's no curation on the words. You could write whatever. And some people actually put like, you know, they make mistakes, or they put like big, I should maybe check because there might be some really like racist, a lot of stuff there by the time. But that's the first point. The second point is that what I see is, to me at least, the future for now of art made with AI is not OpenAI DALL-E. That's because like there's so much red tape to these technologies, and to me they're way too constraining. They will be useful, you know, because now like anybody like who wants to draw some picture, they can draw them very fast. So it's a useful tool. But I don't think this is where, at least to me, where the future of AI art, this is the mainstream. This is not AI art anymore. It's like mainstream art, like it's NFTs. Where it lies is probably more in like shallow learning approaches, where you can work with your own, maybe smaller databases, maybe use some pre-trained models that you can increase. So there will be, but to be able to play, you need to be able to play. You can't play with a system that costs like millions of dollars to train, that belongs to a company. You can't have an unless maybe you have one day an open source version of it. But the problem is that the problem is that with the open source revolution, we could use code and it was free, right? But this is not free, and people don't have the databases are not free, and there's some really big problems with, like, if I want to make my own, even if I have the code, I can't make my own DALL-E because I need the data, and I won't ever get that data, right? So yeah.
Sorry. We're out of time, really, seriously. And thank you so much. I hope you can continue the conversation outside. I just want to leave registered that Rosemary sent a question, which we didn't have time to read, and want to thank her and you and all the audience for bearing with us and contributing in your way. Thanks so much.
I have to run, but I would like to continue.